why it is important and what's there for you guys to look forward to. So first question is, sorry. The first question is, who am I? My name is Shivom Aggarwal. I have done my computer engineering with specialization in information security from India. I am a certified ethical hacker. I'm also a Red Hat certified engineer, Cisco certified network security expert, and I've also done on the finance side, which is like completely different, but still my CFA, Chartered Financial Analyst. I've done the Master in Management, the same thing where you guys are doing right now, with specialization in digital business. I've been working after that in mergers and acquisitions for high-tech companies, generally across Europe and in the United States, in Munich. Right now, I'm doing my PhD in IE. I'm working with Professor Claudio with CEDIN. We also work together with the European Union, working on policy making for future technologies. So this is more or less what I've been doing and who am I. So I want to keep this presentation more interactive, so you can ask questions anytime you like in between. So the main idea is, I'll start with an interesting video. Maybe some of you have already seen it. There are more honor kids in India than the kids in rural America. These are some facts. The more important fact is this one. The top 10 in-demand jobs in 2010 did not exist in 2004. We are currently preparing for the jobs that does not exist now, using the technologies that have not been invented yet. There will be, in order to solve the problems that we don't know yet, and it's going to come. People switch jobs more frequently than ever before. There are less than 1 people working in one job for 5 years. The technology is improving every day. Now people are using more and more technology in everyday life, in everything. Now it's above 1 billion already. Facebook is now available in 70 languages. Not only Facebook, there are other social media networks, especially from China and other countries, which have equivalent number of users. We're literally living in exponential times. There are 31 billion searches on Google every month, which is huge. This was just 2.7 in 2006. We can even divide the technology timeline between before Google and after Google in many respects, especially in search engines. So this is overall the main idea of this thing. So the main idea is the technology is changing. It's evolving. It is evolving fast. And it is evolving faster than we can think, we can imagine. Why this is important? Because we are creating data. So whatever we do online right now, we are creating data. We are creating huge amounts of data of very different types, sometimes structured, sometimes unstructured. For example, Twitter or Facebook or any kind of social media, we are creating data that is unstructured. We cannot store that data specifically in an Excel file or any kind of relational database. So we can actually look the data from a perspective of volume, velocity, and variety, where you try to visualize the data from 3 dimensions. So we can actually classify this data, which is very difficult at the moment. And some of us, yes.
Sorry for interrupting, but in order to catch on the presentation, can we go back 1 second to the previous slide to say what you mean by volume? I guess the quantity of data we're facing, and by variety and velocity, what do you mean?
Okay, yeah. So volume is the size of the data. We are dealing right now in petabytes of data, which is even larger than 10 raised to power 4 times the size of the data. We are also working in variety. There are different varieties of data, as I was mentioning, structured and unstructured data. So what it means is sometimes you cannot store the data. That right now we are using mostly databases of Oracle, designed by Oracle, mostly in terms of relational database, in which you store everything in the form of tables. You create indexes and you store it there. But it can be unstructured. How can you classify and store a Twitter feed, which you cannot even sometimes, a machine cannot read the meaning of it? When you talk about velocity, we are talking about real-time data streams. Right now, we can capture data streams from traffic lights directly, live. We can talk using Skype anytime, online. We are storing the data, so data is real time. And sometimes the data is velocity is much slower. It goes much slower in terms of not real time. It's stored in the databases, and you retrieve it later. So it's generally measured on volume, variety, and velocity. Yeah, good question. So now, some of us, as academic researchers, we are calling it big data. There is not, until now, till date, and Claudio can say this or not, I'm not sure, that we don't have a clear definition of what is big data. Some of the leading researchers, they are calling whatever kind of data that makes us look beyond the technologies currently available is called big data. Some of them are calling it a combination of unstructured and structured data, which we cannot analyze with the currently available technologies. So it's a complicated terminology. People still don't, researchers, academics don't even, they are still concerned that whether this is a concept, is it just a term, or whether it is much bigger than that. Why we are having this conversation now? Why big data is becoming so important? Web 2.0 is passing. Web 2.0 included things like social media, Google search, YouTube, where you share video sharing, every kind of sharing. What the main idea behind Web 2.0 was the new information was being created by us, by users. Web 3.0 is coming. Web 3.0 it includes a concept of technologies where the new information will not only be created by humans, but also be created by the machines itself. There is semantic web technology. There are MUVE, there are new avatars and stuff where you talk about the machines will create new information. We will provide them data, but they will create the new information, not necessarily only us. Artificial intelligence. We have been hearing this for a very long time. It's not so far. It's, we are developing self-learning algorithms at the moment. I'm working on a project with a professor from Germany where we are trying to develop a self-learning algorithm to classify unstructured data in real time. So we are doing these things right now at the moment. So sometimes why these self-learning algorithms are important. It sounds like a science fiction movie, but it is happening in reality right now because these algorithms can bring to insights that we cannot even think about existed there. Connecting the data from traffic lights to housing to GPS data to your phone usage, connecting that to your Google search data, to your emails, to everything, and bringing the insights that we cannot even think about at the moment. So where does this data come from? We always say, okay, there is huge amount of data. Okay, where it is coming from? It is coming from, for example, social media. Every kind of movement we do on internet at the moment brings new data. Cities, smart cities. Me and Claudio work specifically on smart cities, where we try to figure out different kind of data strategies and how you can make better policies for smart cities. There you can have data from traffic lights, from water utilities, from electricity, about housing, about any kind of transportation, metro lines, bus transport. Why this can be useful? This can be used in many ways later. We can have data from satellites, of every kind of data, from weather forecasting to GPS to telecommunications. Now we are in a network where we are consuming and producing data every second. Why this is important? This sounds like too far technology. Huh? Maybe it's not applicable at the moment. It is. There was a company called Aggarwal Capital. They designed a hedge fund, an algorithm to trade just based on the Twitter. So what they were doing is, they were getting the Twitter feeds, they were analyzing it, and they were taking the sentiment of the public. They were getting tremendous amount of data, billions of Twitter feeds, and they were checking whether, for example, Apple, people are thinking positively, neutral, or negatively about Apple. If they are thinking positively, they will invest that the stock of Apple will go up. If people are thinking negatively, the stock of Apple will go down, and they were beating the market. This was 2011. Right now, McKinsey says that if US healthcare uses big data in a creative and interesting way, they can save $300 billion every year, just from the healthcare. There is a possibility of saving $1 trillion just by the United States, and around $2 trillion just by the European Union, if they use the big data in the right way. Again, this was 2011. IBM says that, according to their market research, there is a possibility that if utility companies like water, electricity, even internet service providers, if they use big data, they can improve their accuracy 99%, which is very high. Because we are dealing with 2.8 petabytes, which is 10 raised to power, as far as I remember, 16. So where can we see the use of big data every day? We see in Netflix how we get our recommendation to watch the next movie, or Spotify, which music our friends are listening and what we would like to listen. Amazon, which books we would like to read. The recommendation algorithm of Amazon is considered to be one of the technologically advanced algorithm present at the moment in terms of recommendation systems. Google, searching. Do you remember, like few years ago, you didn't used to get, when you start typing a word, it was not automatically completed. You're not getting the drop-down menus. Now you're getting them. So they already know what you want to search, or what you would like to search. You just start typing one letter, you start typing C, the Google will say, okay, you are looking for cars. Because they are starting to know you. Right now, it is possible to locate a person based on triangulation of data from different sources, where he is or what he is up to doing, up to 3 to 4 hours, what he is planning to do. We can use in more advanced things like human genome project, where we have already mapped all the human genome sequence. What can we do with this mapping? We can create new genetic medicines. We can create new improvements in terms of using the data to cure. We can improve policy making. Where to put the next metro station? Where to bring out, create new special economic zones? Should we invest more in manufacturing, or should we invest more in service organizations? Which technologies should we put our money on? We can think about unmanned vehicles. Right now, in US, on experimental basis, Amazon is trying to deliver their packages through helicopters, unmanned vehicles. In India, in Mumbai, there is a small company which tried to deliver pizza through unmanned vehicle. So there are a lot of possibilities that you use that big data. Even in SETI, We can think about extraterrestrial life. We need huge big data capabilities to analyze the tremendous amount of spatial data to figure out where the next life form can exist, or does it exist at all. So what could be for you in big data? What could be we can look for in the big data? There are a lot of new jobs that have started to come up, which didn't exist a few years ago. One of them is being a data scientist, where you combine the skills of mathematics, statistics, business acumen, and programming. You can be a data engineer, where you try to design algorithms to analyze the new kinds of big data. You can try to be a data analyst, where you try to think about how you can combine different kinds of data and come up with better insights. You can be a big data consultant, where you can consult with companies what kind of data they can capture or gather or they can use to have better business decisions. And every other industry that uses large amounts of data. Why big data is so important? Because big data can create such insights that can be used not only by scientific advanced researchers, but also by everyday business, by policymakers. So it can influence every single day. So far, any questions? Anything that comes to mind? Yeah.
One thing that came to my mind was the IBM Watson. I don't know if you
Yes.
aware of it.
Yeah.
So
the supercomputer.
yeah, exactly. So how do you see it like changing our lives in the near future? Because they are trying to incorporate, I think, even mobile applications to it, where it uses data to provide like unique solutions to people, maybe in terms of shopping, healthcare, or
Yeah. Right now, there is a prediction. Maybe some of you are familiar with Moore's law, which says that Morse was one of the founders of Intel, which says the hardware technology improves, it doubles every 18 months. And the time has reduced right now to 4 to 6 months. So we will be able to produce supercomputers like Watson at a cost of $1,000 by 2030 or 35. That's estimated. So then, right now, the resources are limited. So in terms of Watson, there are very few supercomputers around the world. Maximum number are present in China at the moment. So in that scenario, when we will be advanced enough, then we will be able to analyze every single amount of data, and we can actually create better mobile apps. So apps like Siri is what, for example, let's take an example of Siri. Apple, so when Apple created Siri, the main idea was to have a digital, your coordinator, a digital person who will always be with you in creating or helping you in your scheduling your daily lives in everything. This is a novel idea, but once you have supercomputers, you can actually have proper digital subordinates who will do everything for you. They can write your assignments. They can create whatever kind of report, whatever kind of, if you want to book a ticket, they will book it automatically. So it's going to be possible, but not yet. Yes?
I'm wondering if you can tell me a little bit about how artificial intelligence algorithms can deal with natural languages in different types of languages, and also when you're thinking about mathematics, how artificial intelligence can deal with that.
Natural language, that's a very, very interesting thing. So we are facing a challenge on my project with a professor in Germany, is that it's very difficult to map the human perception of languages. And without that, we cannot really analyze unstructured data, like Twitter feeds or Facebook kind of data. So at the moment, what's happening? We are creating some frameworks in which we are giving, for algorithm, for what's happening. We are creating frameworks, a data set, where we are teaching the algorithm how to differentiate between different texts, different words. Once they learn that, we can use it to work on unstructured, completely unexplored data.
But that means a lot of manual labor.
Not so much. We have decreased it because before that we were working more on supervised learning, which we call supervised learning. We were teaching everything. We were feeding every kind of benchmark to work on. Right now we are just giving them a training data set where the algorithms train themselves on that, and then they can work on unexplored data completely, and you don't need to touch anything. So we are going towards there, but it's still a bit far. There is a group in MIT Design Labs which are working on this aspect of artificial intelligence, where they're trying to combine human neurobiology, where how we actually map how the electrical signals works between the neurons, and to take the same neural network approach to build the algorithms. Yeah.
You said you were researching on smart cities, right?
Yes.
So, of course, in a city like Spain, for example, it's by 2020, there's full-on adoption of like smart city gadgets and whatever.
Yeah.
In that particular field, what exactly does big data, role does big data play? Only in terms of forecast and pattern recognition, or are there more applications?
There are several applications. Thing is, the main concept of smart cities revolves more or less around big data. Because whatever kind of smart decisions you're going to make, you need data to make those decisions. First thing. Second thing, there are a lot of factors. One factor could be, for example, impact. So if you implement anything, okay, let's say we will put a new metro station outside Madrid, on Las Rosas or wherever, and what could be the impact of that metro station? So this is a future endeavor, as Claudio was saying. So think about what's going to impact in the future. What can we do today about that? So we try to create scenarios, simulations, based on the data that's available in the past or currently, to create what can we do in the future.
Isn't that like a never-ending cycle? Because data is always feedback, right? So you get more, you produce more, you get more, you produce more.
That's why we call it exponential. We are in exponential times. The moment we get feedback, the curve shifts. So this is right now how the technology curves looks like. So this is how we go, and then there is a paradigm shift, and the technology curve goes like this. So it should have been going like this, somewhere like this. Or if you go by the idea of technology diffusion, it should have gone like this. So every technology should die. But what happens is it does not die because it paradigmly shifts. New technology comes. So what's happening is here we are mostly right now in these times where the technology shifts are exponential, and they will suddenly change the whole paradigm. More questions? Yeah.
So just one last question. Most of my undergraduate was in search engines,
Okay.
and so I also work a little bit with data management, as you said, data sets and whatever. Biggest issue is noise, which you get from all this data. I'm not sure right now, but I think Oracle is one of the pioneers of eliminating all this, because, of course, if data keeps increasing exponentially, you're going to run out of like storage space,
Yeah.
both from a hardware perspective as well as cost.
Yeah.
So what exactly is happening right now? If you don't mind elaborating.
Yeah. So first I'll start with the search engines. So search engines. I mentioned semantic web technology. So semantic web technology, semantics means you try to figure out the meaning. So what was happening beforehand when Google came up with their first algorithm in 1999, it was based on keywords. It was not based on the meanings. So you were matching word to word. If that word exists in some kind of web page, it will show the results. Right now, what's Bing technology is more advanced than Google at the moment in terms of semantic web. What they are trying is they're trying to build meaning of everything you search. So when you search a car, let's say, old car. So before that, what was happening, if someone would have put like an old lady has a car. So Google will search this. But what you are really looking for is to buy a car, old car. So right now they try to find the meaning of the whole sentence, combination of words, and then try to deliver the results. And for that, we not necessarily need new storage. We just need better analytics. And now we're coming to the question of, we have too much data to store. Do we have hardware capability? Yes, we have. Do we have software capabilities? Right now we can compress the data to approximately 10 to the power minus 12 times. So it's very high. So we have the capability to follow the exponential curves of data growth we have. What we don't have is to analyze that data. That's where we are missing. Right now, organizations like Google, they are one of the pioneers in coming up with analytics and analytics techniques that can work on big data. So you will be familiarized, if not now, soon you will be familiarized with this word. It's called Hadoop. Right now we use Oracle databases, which will be obsolete in coming future. These are the new databases where you store the data will be based on Hadoop. Hadoop is open source technology, one of which is based on a technology called MapReduce. MapReduce, which comes from Google file system. So here you can store any kind of data to up to a size of petabytes. What's lacking in Hadoop, it cannot deal with real-time data at the moment. So Google is working on another tool called Dremel, which they are trying to build on top of Hadoop so that you can actually work with real-time data. So the main problem, storage solved. Storage is not a problem, not from the perspective of Intel, AMD, from microprocessors like hardware, no. From the software side, not really. We have proper storage capabilities. We can store any kind of data. The problem is the analysis. Can we analyze and use this data? There comes the question of, it's not like so when we talk about analyzing the data, there are certain concerns. One concern, do we have the right kind of algorithm or technology to analyze that and create useful insights? And can we do it in cost-effective way? Because cost efficiency is very important in any kind of new technology. Because in the end, we are trying to remove or make the older technology obsolete. So what's the main concern is whether the new technology is cost efficient or not. Right now, it's very difficult to actually analyze, to have a cost efficient algorithm for analyzing big data. So that's where the main challenge is, to develop high efficiency, cost effective algorithms for analyzing the big data. More questions? Okay, so the main idea for the presentation from my side was to give an introduction where the big data, what's happening in the big data. So one of the main concerns right now that academic researchers are having is how you can actually use that data in our daily lives. So can we actually, like people like us, can we have some kind of pattern, usage, tool, methodology to use the data? Because right now it's very costly and it's very technically advanced. You need very high technical skills to work on big data. But can we bring it to masses? Because that's one of the key parameters for any kind of technology diffusion. You have to make it easy for the masses to use it. So there is one concern is whether you should try to work on it or not. Maybe the analysis of big data is only useful for companies or at the government levels. It's not necessarily useful for people in general. So you don't directly target the people, you go through the diffusion channels. So there is a very interesting academic debate going on about this making the technology feasible and cheaper for usage for common people. which is currently very difficult at the moment. There are a lot of groups working in Aachen University in Germany, also working in MIT, Stanford, who are trying to build models, technologies, or tools that everyone can use. For example, everyone, most of us, how many of you use Excel? Everyone, right? So think about you can use a similar kind of tool to work on big data. Right now, implementation of Hadoop costs in millions at the moment if you want to implement Hadoop. But we can work. There are short projects, but you need much more technical expertise, and I think not everyone is a computer engineer here. So how people from economics background, or people from business background, or other like linguistics or marketing or any kind of background can use these tools to come up with, in their daily life. That's going to be possible, but not at the moment. Yeah.
But at the end, Google Analytics is kind of a tool that companies can use.
Yes.
Or Facebook. Like
Yeah.
whenever you post an advert on Facebook, you can get quite a lot of data about how your advertisement is working and what people are saying. So there are tools.
There are tools. There are very basic tools. And most of these tools, for example, Google Analytics. So Google Analytics, that the program that they offer for us, basically works on the similar technology that for actual relation database works. What? Because the kind of algorithm, the kind of data you get is structured, very structured data. How many people visited? How many people bought your product? It's very easy to calculate in numbers. What's difficult is, for example, whether your product is being talked about, how much people are talking about it, whether can it bring some benefit to your company. So there are social media analytics companies who are trying to do this, but their offerings are still very expensive. That's what I'm trying to say. Like most of the offerings that for common people are available at the moment are not really using big data analytics because it's very costly to implement. And most of the big data analytics tools or techniques are still in the research. So this is one of the future technologies. This is not a current technology, this is a future technology that's going to come soon. And the speed is very, very quick. It's going to come. Maybe in a few years you will see that there are products available for our use. But it's still not so cost efficient yet. Yeah.
A small thing about your question is there's, let's say, two different types of challenges. One challenge, and Shivom was explaining along these lines, is that you know what you want to ask. You know which is the question. But there's a second challenge where you don't know which the question is. This type of tools, where you don't know which is the question, but you want something, some new insight, this is the key thing.
Yes. So it's like you create like a robot, for example. You create a robot and you leave it in a big warehouse of data and ask him, find something interesting for me. That's what you do. No, really, that's what you do. When I say self-learning algorithm, that the robot will try to look for small patterns initially, and then building on that patterns and patterns and patterns, he will find those insights that you cannot anticipate that existed. So that's the main idea.
And also because for many companies and for all of these projections, the value is in this unexpected insight. This is where your, I don't know, competitive advantage for your company is. Because you don't really know.
Yeah. So the thing is, like, if you know the question, it's easy to find the answer. When you don't know the question and you don't know the answer, how will you go about it? And how you will assess the impact on your current state or in your future endeavors? That's the question. Yeah.
It's a difficult question. It's like not difficult for me, but difficult for me to ask. Actually. So when you look at a robot like the one from Honda, Simo,
yeah,
right? And I understand that he can answer a question or whatever. He can bring me juice or whatever, or he can even answer a question for me. But just if somebody put the idea into him.
Yes.
So the question is, what I have now is with big data, is it the right approach to really go or really require from the technology that they will answer questions for us we don't even know, or if big data should be a tool to just answer questions we have and we can't solve that much, because the computing, I see the advantage that the computer works much faster and can think much faster as soon as he knows what he has to do.
Yes.
Than when I understood what Claudia told us before, that when we go into a room, we have a perspective on how I look at the table. So the robot will hardly understand the next 50 years what the perspective is, what we are already calculating in our brains. While we think slower than him, we already know what we want to do, because there's so many assumptions going around in our head. So I'm just asking this question: is it the right perspective to really require this, that they will propose us questions, or like the big data?
The thing is, this question goes very much in the line of this debate about artificial intelligence. Should we have the artificial intelligence in the first place or not? Because big data analytics is again going towards the same paradigm. So what we are doing right now, we have approximately mastered the technique of developing algorithms where you tell them what to do. We have very high efficiency, cost-effective algorithms for that. What we want to achieve is the same level of cost efficiency and effectiveness of algorithms where we don't have to tell them. So they can, that's what I was saying. Web 3.0 is about when the machines or algorithms will create new information, not necessarily only us. So they will come up with new information.
But just based on like historical patterns, right?
That's important. So they can only, they not necessarily will be able to work on historical patterns. They will also be able to work on future forecasts. They can make their forecasts themselves.
But if we saw before in the mobile, in the smartphone forecast, if there's no human common sense questioning what the forecast gives us,
yeah,
like the machine won't be able to understand, like, or at least I hope the machine won't be able to understand that they say, oh look, this is actually not, this is not good 2030, it must be something, common sense would be 2020.
Mm-hmm.
Like this common sense part of the whole thing.
Yeah, so what, at the moment, you're right, it's very difficult. We cannot include human common sense in the robotics or in any kind of artificial intelligence, but it will be possible. That's where we are working towards.
Yeah, that's the big question here is common sense something algorithmic?
Yes.
This is the big point. If common sense is something algorithmic, at some point it will be built into any kind of machine. If we do things with our minds that are not algorithmic, then we have a problem. And this was a big debate on this like 10 years ago, 15 years ago. But now more or less everybody agrees that yes, we are algorithmic. The only thing is we are rather complicated, yes. But we are simply different algorithms.
Isn't our
so this is how we say, like, human brain is an advanced form of computer.
But isn't it like our habits are algorithmic, but not our, like sometimes we do things which are not based on our habits, right? Like we can do them 99 times, but the 100th time we do something different, the machine won't get it. Like,
even intuition is algorithmic.
It's algorithmic.
Although you don't realize that these are the frontiers of research, but it looks like, yes, we are algorithmic, although you don't realize sometimes.
Yeah. So again, the question goes back to whether you should go for artificial intelligence. The debate is artificial intelligence possible? It's possible because, as Claudia said, our human brain is very much like a supercomputer. So if nature has advanced that technology already, can't be replicated. That's the main theme. And through we work on basic assumptions, and so far we have been able to achieve something. Not a lot, but we are going towards the same direction. Yeah, there were hands. Yeah.
With regards to the time horizon for us to be able to use big data for us, like for the mass market, like a tool for us to get out information. For example, now I think of when I'm, for example, planning a trip. it says we are forecasting that the prices of the tickets will drop in 2 months.
Yes.
So maybe you might buy the ticket in 2 months' time. So this might be an example of
This-
big data. But
This could be.
this could be okay. So imagine what's the time horizon you expect for us, like having a tool?
2030.
Okay, so imagine by 2030 we have a tool that knows everything about us and that can provide us like future future scenarios or different forecasts about whatever.
Yeah.
For example, I am planning a trip and you should go China because the currency is expected to change and it's going to be good to you, blah, 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 blah. Okay, but if it is forecasting these future scenarios or these hypotheses, for everybody, this will change that it will also change the forecast itself. You know what I mean?
Yes.
Yeah, true.
So there is not,
So there is
it's complicated.